Hello, hello, Professor Fiore here with part 3 of the Pocket Rockit Personal Amplifier video series. So here in part 3, we're going to be looking at the equalizer section, right? Part 1 covered sort of an overview. Part 2 was the preamp distortion section of it. And part 4, the one after this, will be on the output power section. So we're going to look at the equalizer in this video. Big picture. The EQ consists of a 3-band section. This has a shelving EQ, standard shelving EQ for bass and treble. And then in the mid-range, there is a resonant style EQ. Cut boost levels, roughly 15 dB plus and minus. In reality, the treble is about 15, the mid-range is about plus and minus 10, and the bass is about plus and minus 20. I will show you ways that you can tweak those numbers. You might like something a little bit different. Also, I'm going to show you how you can tweak the frequency corners and the resonant points. All right, so you want to maybe play with those as well. Related videos, and I strongly suggest you watch these if you haven't already. There is a video in the Op Amps playlist on bass and treble EQ, and another one on resonant EQ, which would model up the sort of mid-range that we're going to be looking at. So let's take a wander over here to the circuit. Okay, so here's our little amplifier. First stage, this was the drive section that we were talking about, the preamp. So this section right in here, right, with all of these potentiometers and whatnot, that's what we're going to be looking at in this video. This is the EQ section, and then of course out here is the power section that drives the headphones or a small loudspeaker. First thing I want to point out, if you forgot, we're using a dual op amp here. So I'm using in the sim, I'm using a TL081, but you know the dual of that would be a 082. There just isn't a model. There's really no need to have a model for an 082 or an 084, a quad, in the simulator as long as you have one of them, right? So as far as the actual chip that you buy, you could also use a 353, an LF353 would work. They're virtually identical as far as performance with an 082. Or you could go a little upscale and get the newer generation, which would be an LF411, LF412 would be the dual. That has very, very similar AC characteristics, but has better DC characteristics. So things like DC offset and drift are much improved in that one. All right. So anyway, without further ado, let's take a look at our EQ. Hey, that rhymes. All right. Here is the circuit. Like I said, here's an 081. Redrawn, maybe doesn't quite look the same, but it is the same circuit. The first thing I want to point out is the need for bias on this op amp. Now remember, we're using a single 9-volt power supply on this, a single 9-volt battery. So the negative power supply terminal goes back to ground, and in our case, we're going to need half the power supply applied to the other pin of the op amp. This op amp is being essentially set up as an inverting amplifier, which we'll see just in a moment. But we need to keep that, that signal right in the middle, right? In other words, between 0 and 9. So the first thing we're going to do over here with R18 and R19 is set up a voltage divider so we get half the power supply right there, and then that feeds into the plus input. So we have a 4.5 volt DC bias on this. This capacitor C14 shunts this point to an AC ground, so that reduces the chances of any AC noise, ripple and so forth on the power supply getting into the op amp and eventually working its way into the signal. Right, so that's what C14 is doing. And then, of course, we have C15 and C13 out here blocking DC from getting elsewhere. All right. So one thing you don't want is DC voltages on your potentiometers. When these potentiometers have an AC signal going through them, if you're adjusting them and there's a little bit of a discontinuity, a surface dirt or something like that, you get a little scratchy sound. If there's DC on it, that magnifies the scratchy sound. So we want to keep DC off of the potentiometers. All right. Okay, so we have three sections here for treble, mid, and bass, top to bottom. And, off on the left-hand side, this is the signal. I'm just using a generator here, but this is the signal from the preamp. Okay, and the V out that I'm labeling just goes off to the power stage. But in any case, so these three sections, if you've seen the videos on the bass treble EQ and the resonant EQ, these are going to look familiar. So I'm just going to kind of focus in on the treble one first. All right, the other two basically follow. If you really understand how the treble works, understanding how these other ones work, is not a big jump conceptually. Here's the way to look at this. You're essentially looking at an inverting amplifier, right? So across the amplifier, right, from the output back to the minus input, there would be a resistor here, RF. I'm not talking about R17, just ignore that for a sec. So there would be a resistor out here. And then you would have another resistor, Ri, the R in, right? That would be coming off to the driving source. And it's the ratio of those two resistors in an inverting amplifier, RF over Ri, that would create the gain, right? So if I had, a 10K and a 1K, I got a gain of 10, inverting gain of 10. So what ends up happening here, looking at the treble section, I want you to ignore the capacitors, C7 and C8. Just kind of think of these just as a dead short, okay? That guy's gone. This one is open, right? Explain in a sec, but just for now, do that. What you see is R9, R10, and the pot. So R10 is in the RF position, R9 is in the RI position, and the pot is part of it in RI and part of it in RF, all depending on where the wiper arm is. So if the wiper arm is smack dab in the middle, all right, so in other words, I have 50K on this side and 50K on this side, then I have 50 plus this 3.3, that would be the RF. I'd have 53.3K. And the RI would be this half of the pot, 50K, plus this 3.3, right? And you would have, again, 53.3. So you take 53.3K over 53.3K, and you got a gain of 1, right? So there's your 0 dB. That's the middle. Now, if you move the pot this way, toward R9, then you get more of the pot over here for RF. In other words, the RF is bigger than RI, so you get boost. And if you do the opposite, if you move this wiper arm over to here, right, towards R10, then you get more of the resistance over on the RI side. Now you have a fractional gain. So just to keep it real simple, if this was 1K and this was a 10K and this was a 1K, again, no capacitors, at the extreme, way over here, you'd have 10K and a 1K, or they'd be 11K over 1K. For this, you have a gain of 11. If you come over here, you'd have the 1K, 10 plus 1 is 11. You'd have a gain of 1/11. All right? Now, having the capacitors changes things around. In fact, at really low frequencies, if we're talking bass frequencies, both C8 and C7 are opens. So what ends up happening is you wind up with really the position of the treble control not making any difference. If C8 is an open, no signal is going to get to the input of the amplifier. Okay? You can almost think of this, not quite, you can almost think of this as like a summing amplifier, but unlike a summing amplifier, these things are being bridged back to the output. But in any case, if C8's open, there's no path for signal, so there's no real effect here. But at high frequencies, high enough frequencies, what ends up happening is exactly what I described. The resistors have this effect with the pot, and you get either boost or cut. Okay? In other words, the point where C8 starts to short out, that's where you see that. Now, some treble controls don't have C7. They don't have this cap going across. What ends up happening with the response is you get a boost at the high frequency end, and it just stays up 20 kilohertz, 30 kilohertz, 40 kilohertz, 50 kilohertz. Well, that can be a little problematic. You can get maybe radio frequency interference and so forth. So what I like to do is I'll put a little cap across this, so when you get to a high enough frequency, this will short out and you'll be back to the position of a gain of 1. So in other words, really, this is almost like a resonant EQ because of the addition of C7. So you'll get the boost, but instead of staying flat perfectly like a true shelve, it'll come up and then actually start to drop back down again. All right? So that's really just a little enhancement for noise. Of course, that would be required down here for the mid-range. The mid-range is essentially the same thing that we see for the treble. Obviously, the cap values are different because we want the frequencies of interest are different, right? We're going to go to a lower set of frequencies. On the bass, it's a similar thing, except at really high frequencies, what's going to happen is C11 and C12 are going to short across the pot. And all you're going to have for gain is the R14, that's 6.8K, and the R15, that's 6.8K. In other words, a gain of 1. So these open up at low frequencies, and we see, the appropriate cut and boost. So if you want to change the amount of cut and boost, for example, like the bass, right? I say, well, this is going to work out to be around plus and minus 20 dB. If I don't want that much, I can just increase the values of R14 and R15, make them 10Ks instead, all right? If you want to change where the bass response kicks in other words, where it goes from, flat mid-range and then starts popping up, you're going to monkey with the values of C11 and C12, all right? Same thing with the treble. Where does that take off? Well, you can monkey with the value of C8. Now, generally speaking, smaller caps will give you higher frequencies. All right, that's simple. Now, theoretically, you could also monkey with the pot values, but that's kind of impractical because, pots only come in certain sizes. There's a very limited number of pots. You can't go out and find like, I don't know, an 80K pot. It's just not that common. Whereas you can get all kinds of weird values for resistors, 1% resistors, very easy to find. They're cheap. Pots, so we kind of are forced into leaving the pot values the same and then adjusting the stuff around them. All right. And if for some weird reason, I don't know anybody who does this, but hey, it's not for me to judge. Maybe you want more cut than boost or more boost than cut. Well, these resistors on this side don't have to be the same as the resistors on this side. Now, you could make this a 3.3 and, make this a 3.9 or a 4.7, okay? You'll get some asymmetry in the response, but, if that's what you want, if that's what you're looking for, well, you can do that, okay? All right, so now that we have a basic idea of what's going on here, let's do some simulations and see what kind of frequency response we get. So right now, I've set all of these up for 50%, right? All the pots are sitting at least they should be. I'm just going to make sure they're all sitting at, middle. So we would expect no cut or boost. All righty. Of course, this is never perfect. So I'm going to go from 10 hertz to 100 kilohertz, which should be plenty. Boom. And here we go. All right. So your first reaction would be like, oh, wow, that's crazy. Look at this big shift. Yeah, I know. The first time you look at it, it looks pretty striking. But notice what the scale is over here. That's minus 0.1 dB. It's 100 mils. So that's a tenth of a dB. And down here is 1 dB. So you're basically saying this thing is flat within less than a dB between 10 hertz and 100 kilohertz. I think that's pretty good. Okay. All right, let's go and change up the pots. Okay, so I'm going to come in here and let's just push this all the way. I'm going to go to 0%. So that would mean the wiper arm is going to be all the way over here, right? The little marker here, little zero thing that Tina uses indicates that's where you're starting from. That's the 0 point on this end, right? So the pot wiper arm is way over here. And we'll redo this. Boom. Okay, so now you can see the scale has really changed up a lot. So here's our 0. There's that little like dB that we saw down here at 10 hertz. So this comes up, starts to peak, and it's peaking, right? This is 10 kilohertz, that's 20. So it's peaking actually right around, maybe 15 kilohertz or so, okay? 16 kilohertz maybe. And then it's starting to drop off. So this drop off is what I was referring to with C7. If you didn't have C7 out here, this thing would just kind of come up and just flatten out and stay up here. So what I'm saying is you can't hear any of the signal up here. So why keep boosting it? because you could have, like I said, radio frequency or other kind of interference up there, which would, mess up things. So let's just bring it back down because you can't hear it. All right. That's the whole point with that. Okay. So let's go back and go to the other extreme. Let's make this 100%. So crank it the other way. So now with it 100%, the wiper arm's all the way over here. So now the pot is associated with the RI side, and we should get cut instead of boost. All right. Okay, one more time. And there we go, right? So it looks pretty symmetrical compared to what we saw before, right? So the peak is coming in around 15 dB, right? Negative 15 dB in this case. Over here, there was the 15. So it looks pretty nice, as far as the cut and boost behaving in the same kind of way. All right. Okay. Now, let's bring that back to 50. And we'll take a look at the mid-range. So as I said, this doesn't go quite as big. So this will be our max. And we can see what the resonant frequency is in the center. All right, so this thing is popping up. We're getting about 10 dB peak, and that's about 3 kilohertz, right? Thereabouts. Here's your 1K, there's 2K, there's 3K. Remember, this is a semi-log graph, right? Logarithmic on the frequency axis. So that's about 3K, and we're getting just about a little shy of 10 dB boost. And if we went to the other extreme of the pot, we should see a sort of a symmetrical kind of thing going the other way. And sure enough, right, so we're, again, down here at 10 hertz, we're sitting down about a dB or so. And there you go, negative 10 dB, again, about 3 kilohertz. So like I said, if you want to shift this, maybe you want to make this peak 2 kilohertz or 4 kilohertz or something, you just have to play around with these caps, the C9 and the C10. Basically, one of them covers this side of the curve, the other one covers this side of the curve. Okay, so the C9 is going to sort of alter this end of it, right? Because that's where it's shorting out at the high end. Okay, and then C10 is cutting out at the low end. So you can monkey with that. And by the way, changing those, if you change the Q on this, you'll also change the total amount of cut boost. So if you do monkey with these caps, you may have to come back and compensate by increasing or decreasing the values of R11 and R12, right? There's an interaction going on there. So very often these kinds of circuits, because there's so much interaction, it's, it's easier very often. Well, in the old days anyway, we used to just breadboard these things and listen because, ultimately your ears are going to call what's really important. But, with a simulator here, it's easy to just sort of tweak things and burp, 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 and run and kind of get rid of some obvious things that aren't going to work, all right? So you don't just sit there and, calculate, all right? All right, so bring that back to where it was in the middle, and now let's go and monkey with the bass end. So for those of you who really like bass, bunk, all right, so we can get about 20 dB boost over here, way, way down here at 10 hertz, 20 hertz, So like I said, maybe a 5-string bass. I was talking about this in the intro video, right? We want to extend this down. You've got a 5-string bass, your low B string is somewhere around 30 hertz. So yeah, you can get some crazy amount of bass out there, all right? And again, where this actually starts to break off, you just monkey with the values of these caps. And just for the sake of completion here, we can go to the other extreme, right? Full cut. It's bassless. Bonk. All right, so there you go. We're getting actually a little bit more than minus 20 because the system already has a roll-off because of the coupling capacitors. So, we're getting like 23, 24 negative, but there you go, right? It's still essentially the same. And of course, you can come in and, cut and boost. So, I could come in here and say, well, let me give, a little cut in the bass. Or I'll tell you what, let's do maybe something that's a little funkier. Okay. Like you want to do more like a scoop kind of thing. So I'm going to give a little bass boost and maybe a little bit of treble boost. Give it a little bit of bite, okay? And then maybe I'll kick out a little bit of the mids, sort of a scoop kind of thing. All right. I'm just throwing these numbers, and I don't really know what this is going to look like precisely. I mean, I know grossly speaking what it's going to look like, but there you go. All right. So got a nice boom, bottom, little scoop out here in the center, and then a little bit of a rise to, just give you a little bit of attack and edge. And then, of course, here's your 20 kilohertz. So this doesn't really matter. This is outside the range of human hearing. So you really only care about this section like right in here, right? So you got like 5 dB of bass boost, a couple of dB cut here in the mid-range, and then, another dB or so rise at the very top end, right? So that's not like an extreme bit of EQ. But you have options, right? You just start monkeying with these things, and you can do all kinds of stuff. So, just a simple 3-band EQ, you can do a lot with, all right? I think that pretty much covers what's going on here. And like I said, if you want to diddle with this thing, you can do what I did, just put it in a simulator and start monkeying around, or just put it on a breadboard and start swapping out components and play your guitar, your bass, whatever, and monkey with it until it sounds good, right? Why not? A little experimenting is fun. Okay, so there we have it for the part 3. So the next video, we're going to look at part 4, the final part, which is the little power amp chip. And just a little sneak on that, you might decide to use what we've seen so far, the first stage and this stage, and then completely replace the output stage. Maybe you want to build not just a little practice amp, with headphones. Maybe you want to build a little studio amp. So we're going to talk a little bit about how you can replace this last section with something a bit beefier. What's going to be required to do that? Maybe you want like a little 20-watt amplifier or something. You got an 8-inch loudspeaker, right? Now, nothing huge. You just want something kind of simple, okay? But not just for your headphones, okay? Or a little tiny loudspeaker. All right? So stay tuned, and we'll be getting into part 4 shortly. Until then, this is Professor Fiore saying, take care.